for different kinds of flip-flops. And I'm actually going to start, well, I'll start with the D flip-flop because it's the easiest one. And there are different ways to do it, and it depends on what kind of flip-flop you are making. So let's say I'm making, I'm going to do flip-flops and latches. So let's say I'm making a positive edge Can y'all read that back there? No? How's that? Okay. Positive edge triggered D flip-flop. So what does that mean to be positive edge triggered? Right, and so positive edge is rising edge, so that means when the clock goes from 0 to 1. And so I'll just give this a name. I'll call it PEDFF. Okay, and my inputs are going to be D and clock, and my output is Q. And I'll have input D and clock and output Q. I need to make that reg.
What's the difference between putting reg and not putting reg?
So reg is when you assign a value inside an always block. And I'm going to say what Q is inside an always block, and it limits you. It means you can't change it outside the always block. So if you have a longer piece of code, so
Is that just short for register?
it is, but I'm not really sure why, but it is. Okay, so then I'm going to have always at, and then I have what's called a sensitivity list. This means I want you to do what's in this always block whenever one of the variables I put in this list changes. And so here, I want it to be at positive edge clock. And then I could have a begin and end here, but I don't need one because I'm only going to have one statement. All I'm going to have is Q, and then this is the non-blocking assignment. Q becomes D is how I read it. I don't know what the real way to read it is. What that means, it doesn't matter. In this instance, I could have an equal sign. But the reason, what this does is it fixes the values at what they are when you enter the always block. And so that avoids having problems with something. So you've got the whole circuit set up, and you're intending for the values to change all at one time. They're all supposed to change at the clock edge. But if you don't do the non-blocking assignment, it does them sequentially. So you might change something here, and then you need it down here, but you needed the old value, and it would use the one that you changed it to. So like for instance, if I had x equals 5 and y equals 7, and then the point of my always block is to turn x into 6 and z into x plus y. Okay, that's what, and so let's say it turns x into x plus 1 and z into x plus y. So if I did not use a non-blocking assignment, when I would get there, and so what I want is for my answers to be 6 and 12. But if I just did my always at x, y, and begin. And then I have x equals x plus 1, z equals x plus y, end. Then what would happen would be I would get as my output x would be 6, but z would be 6 plus 7, z would be 13. And what this operator does is it says fix the values of x and y to what they were at the beginning. And so when I do this, it will make x equal to 6. And then for z, it will say x plus y, but the x, it'll say whatever x was when I entered the always block. And when I entered the always block, x was 5. And so that would make z equal to 12. So that's the difference between those using the equal sign and using the non-blocking operator. And then this is all that a D flip-flop does, and so I can end module. Okay. Yeah, I could also have, if I wanted to, if I needed a negative edge triggered one, I could have negative edge. So I could change that. Now, let's say I wanted a latch. What's the difference between a latch and a flip-flop? Okay. Right. So you can have a gated latch, or you could have just a plain latch. And so a gated latch can only change when the clock is 1, and just a regular latch would change whenever. So a regular latch would look like this. So I don't need a clock. And since the whole point of my always block was to deal with the clock, I don't need an always block. If I don't have an always block, it doesn't need to be reg. And I don't have a clock, so I don't know why I went and copied all that, because I erased all of it. I forgot my begin here. No, it doesn't have a begin. It just has an end. Okay, and then so all this would do would be, I would say, assign Q equal D. Now, actually, you know what? I probably would put an always block, because I don't want this to just happen once. So I'm going to put an always block. I say always at, and then whenever D changes. So whenever D changes, Q equals D.
So then we can put the
I'm trying. That's a good. I was.
I think it's just good habit. I mean, I don't think it's.
Well, I don't know. It would give me an. I don't know if it has to do with whether I did a non-blocking assignment or not. So I will. I will say. I will. Yeah. I will do reg, and then I like to use this, so I will.
So would you put end and then end module, or would you just keep end module?
Would I do what?
Would you put end after the always block?
Well, I didn't put a begin because it just had a single line. Right. Right. Okay. Now let's say I had gated D-latch. So if I have a gated D-latch, So this, I'll change this. The difference between a gated D-latch and a D-latch is that a gated D-latch, it can only change when the clock is high. So it does have a clock, but doesn't just change on the clock edge. So,
You said it changes what?
That's high.
yeah, so like for instance, if this is my clock signal, and this is D, then Q, let's say Q starts at 0, Q will change whenever the clock is 1, but when the clock is 0, it won't change. So, so Q starts at 0, and then it's in here, the clock is 1, so it can change. But when the clock is 0, it can't change. And now the clock is 1, so it can change. I lost my eraser. And I changed the width of my pen. And then can't change when the clock is 0. Nothing happens when the clock is 1. The clock is 0 here. It gets here, and then it can change again. So it's like it's not active when the clock is 0. So here what I would do is I would add a line, and so always at D. Yeah, I'm only interested. It's not going to change if D doesn't change. I would say if clock equals 1, then we'll let Q equal to D. And I don't have to put an else, because the else would just be don't change. Okay, now let's do, I'm going to do, just for practice, because you're supposed to know this too, or you're supposed to know how to use primitive specification. So you may or may not remember, and I usually don't remember, but what a JK flip-flop looks like in terms of gates. Okay, so this is a JK flip-flop. That's not a JK flip-flop. You can, there's not just one way to do a JK flip-flop. I wanted to do one that just used NAND gates. Okay, so that is the circuit for a NAND gate. So if I wanted to write Verilog for this using just plain logic gates, so primitive, what's the name for that? Primitive, drawing a blank. Let me look at your study guide because it'll be on there. Structural code, primitive structural code. So we're going to use it just by actually saying what the gates are. You could also do it with assign statements. Yes.
What's connected? Is that the bottom left main gate? Is it connected to Q or Q not?
To Q. Okay, so we are going to write code to do this, just saying directly what gates we're going to use. Okay, I'm not. Okay, so this will be module JK flip-flop, and our inputs are J, comma K, comma clock, and our output is Q. Input J, comma K, comma clock, output Q. And I have some internal connections that are neither inputs nor outputs. Those are wires. And so I will call this, just for myself, I'll call this NAND gate 1 and 2 and 3 and 4. And so I'll call I'll have wire NAND 1 out and NAND 2 NAND 2 out. All right, and then when you're specifying things at the gate level, then you you don't actually have to, if I remember right, you actually don't have to use the wires. You can, but I don't think you have to. I've done it before without it. So, all right. So what you do is you just type the name of the gate, NAND, and then you say what the output is. So the output comes first. So I'll say NAND 1 out, and then you put your inputs. And I have my inputs for my first one are J, comma clock, comma, Q. Or is it supposed to be Q bar? They might have assigned their NAND gates differently. It was supposed to be. It was supposed to be this wire is wrong. This one was supposed to be there. So because of that, I'm going to go ahead and make a separate output. I'm going to do my Q bar as a separate output. So I'll just put Q bar, and I'll put Q bar right here. What's that? The squiggly thing, I don't know if I can combine that. What I would do here, if I wanted to, I could also do not Q bar. I mean, there are such thing as just a not gate, but I actually have it as a separate signal in my circuit, so I might as well do it, like, because it actually is something different. It's not just the not of Q. Okay, and then I would do NAND 2 out, and that one has clock, K, and Q, and then I have NAND, and my output for my third one is Q, comma, and my inputs are NAND 1 out and Q bar, and that's it. And my last one, yeah, I needed the Q bar anyway because it's the output for this last one. Q bar, and then NAND 2 out, and the other input is Q. And that's it.
Is it supposed to be 1 and 2, or is it 3?
These are 1 and 2 because they're inputs. Because it is what that is. So.
Oh, I see. Yeah, I got it.
Okay. All right. Let's see. Would y'all like to look at okay, so these are the different things that I think might be useful. So doing how you would do the verilog with a case statement, like if you had to do a hypothetical flip-flop, difference between serial and parallel registers and shift registers and universal registers, and modular verilog, so verilog where you're using code from another module in a given module, and I don't have time to do all of those, but those are things that I could do. Any of those sound better than others. Yes? Yes.
Is it case sensitive for
Yes.
for wire like NAND 1 underscore out?
Yes.
So it has to be lowercase?
Yes. No, you could make them uppercase, but then you have to use it the same all the way through.
Okay.
Yeah. So it is case sensitive, but case sensitive to what you put in.
Okay.
Yes.
Is the wire the connecting the two NANDs?
Yes.
And the Q bar, why couldn't you use like the little squiggly?
So because Q bar in this circuit is really not the NOT of this Q. It's the output from this NAND gate. And so if I'm testing this to make sure that this is really working like a JK flip-flop is supposed to work, I want to make sure that output really does match up. And so then I would do a test bench or something to check and make sure that it did in fact, it was in fact Q bar.
Okay.
Okay, so any of those things sound good to y'all? Registers? Okay.